Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. And as you can see, I've got myself here a good old DC upside down DC audio output section here. This is the 10K board, which, to note, guys, I do not service the 10K boards as of the beginning of 2024. I will service the other DC amps, but I won't take in any more DC 10K boards. Interesting reasons, but I won't. So I was just going through, getting ready to repair this board, and I figured, yeah, let's go ahead and fire up the cameras and show you guys what I do to determine the status of a board, or to begin the repair process. So let's flip this thing around. Since I already did one side, as you guys can see, there are some missing transistors here, and poof, hey, there's a meter there. Oh, sorry guys, I kept getting disturbances. But where was I? Oh yes, I had removed the one side already. So I was just diagnosing the shorts. So I always say the first thing to do is to get rid of any shorts that are going to be present. That was interesting. Well, hopefully we don't have a shorted inductor. I don't think so, but yeah, okay. I digress. But I pulled all the short ones, and now I'm showing here the 24K. And I get questions, people ask me, well, what's the right resistance? The resistance is whatever the pull-down circuit is. So you're going to have resistors in series or parallel or whatever the topology is of the amplifier. But what I'm doing is I'm looking at the pull-down value. So we're going to have, what, 100K resistors. I'm not sure you can just see it. So we have the gate resistor here, the big, what is that, a 2-watt resistor of 38.7 ohms, which is orange, white, black. What is that? 39 ohms. That's the gate resistor. But what I'm looking at is the pull down here. So the pull down is 100K, and you have 4 pull down resistors in parallel, 4 high, 4 low, because this is a IRS 21844. So you have 4 high, 4 low, 4 high, 4 low. So 400K resistors in parallel comes out to 25K. It's 25, 25, 25, 25 equals 100K. That's just your your theory behind series and parallel resistors. And that's what I'm looking for, is the pull down value. If you have a bad transistor, you're going to find a value. Let me flip my leads around. And yes, my leads, I always go black on the gate. I just try to keep things in a normal order. You're going to find that here it's showing 78.6 ohms. So I know right off the bat that this output circuit has a short, because I'm not reading my 24, 25K pull down value because I have a shorted transistor. Sure, you can use diode mode. Heck, let's go ahead and switch to diode mode. Using my meter upside down. Beep. Yep, it'll beep at you. 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 And if a person's not familiar with knowing what forward voltage is, did you guys just happen to spot which transistor was bad? Was the one causing the fault? Did you see it on the meter? I did. But at the same time, I have this beep going on in my ear over here, and that's something I don't want to listen to all day. So I use resistance. This transistor showing 78.7 ohms, 78.7 ohms, 78.4. Sorry for that little bit of a glare there from my lights. Oh, what's this? 0.4. So there's a dead short between the gate and source across this transistor. So then what I'm going to do is I'm going to take my trusty little clippers here. Oh, and not lose track of which transistor I was just on. Usually what I'll do is I'll just bend the transistor to show me which one I was talking about. And then what I'll do is I will take that transistor and cut it out of circuit as I get thermal paste on my pants. Then I'll test it again. Oh, lo and behold, there's my 24.89K. And I'll get to you in a minute here why the next step in my process is I'm looking for the proper pull down values. So it's what do we got here? We have 2 drive ICs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's 8 and 8. So it's 4 and 4. 4 high, 4 low, 4 high, 4 low. So 1, 2, 3, 4. So that had to have been either the high or low. I don't know which one. I really don't care. So I'm going to move to the next set. And the next set is showing a short. 78.2, 78.4, 0.5. Well, there it is. I'm just going to give it a little bit of bend to identify which one it is, because I'm going to cut it out, throw it in the garbage can, check it again. Oh, look at that, 24.94. So there, that just freed up, again, it's either the high side or low side. I think that is the low side. Is it? Nope, high side. Drain is connected to the inductor. All right, so it cleared that one up here, so the next 3 are going to be just fine. Oh, hold on. I digress. 1, 2, 3, 4. 1, 2, 3, 4. Oh, okay. So that finished off the first IC. Now we're going to move to the next one. Oh, and that is another dead short. 0.3. We know that's a dead short. Because what's 0.3 of an ohms? Ohms? 0.3 of an ohm? That's a shunt resistor. Oh, that was a funny. It really wasn't, but I cut that out, and now we're 24.9. So that tells me that this high side is now clear of a short. And let's move to the low side. Well, in just a second here, let me just finish off the high side. The low side, oh, 1.7 ohms. That's a little higher than a dead short. 159. Oh, 79. 79. Hold on, there may be 2 damaged transistors here. Oh no, 1, 2, 3. So they're all 79. Just had to go and charge up a little bit of a capacitance there first. So there it is, 1.6 ohms. Again, 1.6 ohms is a short in a drive circuit. Cut that out of there. And there we are, 24.79, 24.8. And the reason why it's not exactly 25 is because the components and amplifiers aren't to the tolerance levels of military spec grade. So there are tolerances in these resistors, so they're not exactly 100K. And then at the same time, as I'm testing these, it also tells me the condition of the drive circuit itself. If you had, I'm just checking the gate resistors of the transistors that I pulled out. If you had a low resistance value even after cutting out your transistors, then you know you have bad drive ICs, you have bad buffers like the MIC 4452s for the S&I design boards. So that will tell you there's something else shorted down the line. So now that I've cut everything out and everything is 25, roughly 25K per what I call quadrant, then I know that my shorts are gone, and I'm good to continue my testing. What I do is I check drain source, make sure I don't have any drain source shorts. What you're going to find is just some capacitance building up on your meter. Sorry, as I reach across the board, I don't want to mess up my layout here. What I'm looking for are drain source shorts, which is rare. If you had a drain source short at the voltage these run at, the transistor would not have its top anymore. But I double check everything before even remotely applying some form of power or voltage. So then I check other items. So we know we have failed transistors, so needs new transistors. It's going to get 4 new drive ICs because all 4 quadrants had shorted transistors. It's always a good idea to replace your 21844s. Why? Because there's no buffer. There's nothing in between the IC and the transistor to carry the load. Why? I don't know, but I didn't design it. But what I do is I check the auxiliary circuits. I just want to make sure that my voltage regulators are not shorted, which I highly doubt that they are. I already know why this amplifier failed, so I want to check other items that are downstream, that are part of the output board. Why? Because this thing failed from too high of a voltage. So the regulators look good. You have inductors here. Let me see if I can do this without blocking anything. Check your inductors. This is the voltage regulators here that are referenced to negative rail. Beautiful. I check the inductors that are responsible for the drive card. Make sure none of those are open. Looking great, looking fabulous, looking spectacular, looking great. Nice. And then your plus minus 5 and your plus minus 12. I wouldn't expect any other issues on this board. So in reality, what I can do is I can hook up my low voltage power supply to the board and fire up the output section and check the status, of the drive circuit itself, which you can always do. Oh, hey, this board oh, it was set up in strap mode. Maybe I bumped the switch. Not sure. Oh, someone has worked on this before. Oh. Somebody has been here. I digress. But yeah, I could fire it up and test it. I'm almost pretty sure that, it's either going to work or not, but most likely it's not, because these 21844s, I don't want to say they're junk, but I don't like to see them being, having transistors being directly driven off of them, because it does damage the IC. So, but yeah, so at this point here, I'm good to pull the card, replace the ICs, and pull the transistors and put this thing back together. So I just wanted to show you guys how I run down a board and clear the faults to a point where I know now that I'm good to go ahead and rebuild it. So if you cut your transistors out and you still have low ohm resistance values somewhere, you have a fault somewhere else. Always clear your faults before rebuilding a board. Always clear the faults before powering up a board. Know the resistance values that you're working with. And once you understand those concepts, these are a piece of cake to get on the bench, pull the parts, clear the shorts, replace the parts, fire it up with a low voltage supply, check the signal. If the signal's good, slap the boards back together, heat sink, clip the transistors down, test her out. So that's how I do these boards. So if you got any questions, please leave them down below. Feel free. Please like and subscribe. Hit that button. My channel's been growing. I know it's been rough on videos, getting them out because I'm a super busy person, but I try when I can for you guys. And here I will show you how to set up an auxiliary supply once I get this rebuilt and do some initial testing. So thanks guys for watching. If you got any questions, leave them below. Thanks for watching. Catch you in the next one.